We're here at the DevOps Talks conference, and now we have 3 attendees with us. Maybe you could introduce yourselves.
Hey, my name is Ollie. I'm the head of engineering at the Iconic.
All right.
I'm Pav. I run DevOps at finder.com.au.
My name's Alex. I'm a senior DevOps engineer at Answerada.
Excellent. So, Alex, how have you found the conference so far?
I've been really enjoying it, actually. Yeah, there's a lot of focus on people problems, which is the harder parts.
Right. Yeah. What about you? What's been your top takeaway from today or yesterday?
Sure. I really like the talk about Rancher, just to see how they pivoted. Last time I looked at it was like 2 years ago. They've changed it a lot, and it's now an interesting product.
Yeah, it's really cool to see how much technology changes, either when we look at it at an aggregate or at a specific product.
Yeah, absolutely.
That's cool. And for you?
To be honest, I've loved the cultural side of things, and as you see, I've taken away pages of notes, which is actually a really good sign of a conference.
Yeah, and so what will you do with those notes when you get back to the office?
Hopefully restructure my teams a little bit.
Okay.
Rethink our ways of working, and maybe refocus some of the teams a little bit just on maybe, learnings.
Yeah, that's awesome.
Yeah.
That's awesome. Is this the first DevOps Talks conference that you all have been to?
DevOps Talks, yes.
Yeah.
Yes?
Yep.
Yeah.
Hello everyone, thank you for coming to the session. My name is Alena. I'm a principal software engineer at Rancher Labs. Originally I'm from Eastern Europe, so my native language is Russian. And I immigrated to United States in 2007, right after finishing college. And my first job was working on the load balancing and application firewall. And that time I thought, what an uncool job it is. Like all my friends were working on web startups, and I felt unlucky. But then I've changed my mind. And my next job was in infrastructure domain, and the job after that, and I feel extremely lucky working with the technology. So now I work with Rancher. We have a bunch of open source projects. One of them is a minimalistic operating system. And another one, the bigger one, is the multi-cluster management system. It's all completely open source and written in Go. And today we're going to be talking about building hybrid cloud with Kubernetes, why you need the hybrid cloud, and what it actually took us to build the platform. So I'm going to be talking a bit from the developer perspective. I'm going to list the challenges that we faced and the approaches that we've taken to resolve them. And I'm curious how many of you are using Kubernetes today? All right, cool. And how many of you develop in Go? Oh, cool, awesome. Yeah, I hope the presentation would be useful for developers as well as DevOps. So let's reflect a little bit on the infrastructure evolution timeline. I love history because history is a great way of looking back and figuring out the patterns and the common approaches taken to the technology. So on this timeline reflects the need for sharing the resources like CPU and memory. And so it started with the virtual machines. As the virtual machines came the need for the systems to orchestrate the VMs. Systems like OpenStack and CloudStack. I actually did work on the CloudStack. It was fun times. I was young back then, and I could spend like 24/7 at work, and I really enjoyed it. Then the company got acquired, and in 2013, when the Docker containers came out, the Rancher was founded, and I was invited to join them as a software engineer. And similar to the virtual machines, there came the need for orchestrated systems for Docker containers, like Docker Swarm, Kubernetes, Mesos. And then there's a data center of the future, and the future is bright, and we're all going to be a part of it, and we want to see what it takes together. So Docker containers. The containers started shaping infrastructure in a big way in 2013 when Docker came out. The technology behind Docker existed well before that, and what Docker really did, they delivered it via using very good user-friendly APIs. So it was very easy to launch the containers, to ship your software in a secure way, and deliver it fast, either to the production or to other members of your team. And there are alternative container management systems like Rocket, but Docker is by far the most popular one. I don't think if it's going to be true next year or the year after that, but today it's the way it is. And how do you start developing your application and packaging it into a Docker container? You usually start by developing it on your local machine or in the virtual machine. And sometimes your app, originally, it gets started in one Docker container. But then, slowly, things evolve. And you realize that one Docker container might not be enough. And you might want to have the database in one container and then the web in a set of other containers. And they all have to talk to each other. So there's some sort of service discovery is needed. And then you don't want to publish access to your containers just by opening the ports on the host. You want to put it in, behind some sort of a load balancer so you can manage the access better. So that makes your application more complex. And your application needs to be scheduled on more than one host. And you might want to dedicate a set of hosts A to one part of your application and another set to another by labeling the host. So you need some sort of the magician. So you need an orchestrator that would do all the magic for you. So the orchestrator would manage the application scheduling. It will configure and monitor application health. And the important part is nowadays, the updates are shipped so fast. So you need some way of seamlessly upgrading your application with a zero and downtime for your users. So you need an orchestrator. And Kubernetes proved to be the most popular orchestrator out there. And it became obvious in 2007. And we're actually watching the rise and fall of different container orchestrators starting in 2016 when in Rancher 1.x version, we delivered Mesos, Swarm, and Kubernetes to our users. And we're kind of watching which adoption will take the first place. Docker Swarm first version was pretty buggy. The second version wasn't that much better. So they kind of like split our users between Mesos and Kubernetes. And Kubernetes won the big way. And why is Kubernetes so great? So it's the fact that it got developed in Google and that it was used in-house for their application, it proved to be the key point. Also, it's very feature-rich, and it's very extendable. You can extend Kubernetes in many, many ways, and I'm going to go over it in one of my future slides. And it has a very great community behind it. There are like so many engineers contributing to the Kubernetes open source. The code is out there, and it's anybody can contribute to the Kubernetes itself or to the entire ecosystem behind it, to any of the component of your choice. All right, so Kubernetes is great, but nobody said that Kubernetes is easy. So Kubernetes itself consists of multiple components like etcd database, Kubernetes API server, and then cloud controllers, scheduler, kubelets, kubeproxy. To understand the structure of the Kubernetes, it really, really takes time. And orchestrating an orchestrator was challenging. So this guy on the slide, you probably know him. That's Kelsey Hightower, a very popular guy in the Kubernetes community. So he actually wrote a doc installing Kubernetes the hard way. He was actually following all the steps that were documented in Kubernetes just to prove that installing Kubernetes is not a trivial task. So installing Kubernetes was hard. Upgrading Kubernetes was even harder. Some versions of Kubernetes, like if you upgrade from major version to another major version, I do remember that all your user application pods were killed and recreated, and it was release noted for many releases, so it's okay behavior. And of course, it's not an okay behavior. And then the startup requirements for Kubernetes, it really varied depending on where you install your Kubernetes cluster, whether it's on the cloud or on-prem. So, and these challenges got addressed with time. So it got better. The tools started evolving around installing Kubernetes. So tools like kops, the most popular one installer on Kubernetes on AWS. Then the kubespray and kubeadm emerged. And then last year, the major public cloud providers started offering Kubernetes as a service. So now you can go to Google GKE and launch your Kubernetes cluster with just one click and by choosing a couple of options. And the same with Amazon EKS, and DigitalOcean have their in beta, and Azure has it too. So it did get better. So now you can install your Kubernetes using some tool. You don't have to write your own set of scripts of managing your Kubernetes clusters. It's all going to be done for you. But is the puzzle really complete? So we have Docker, who launches your containers. We have Kubernetes that orchestrates the Docker containers. And then we have a cloud provider or any tool that orchestrates your Kubernetes clusters. So does it mean that there is no work left and like everything is done and figured? No, because nowadays you might want to need more than one Kubernetes clusters. And you might want to choose to run some of your clusters in the cloud and some on-prem. I've rarely seen the situation where you actually split your Kubernetes clusters between the cloud providers, because sometimes like you have a preference when it comes to the cloud provider. But I've seen a lot of situations, and I've seen like it happening in a lot of companies where you want to run some of your Kubernetes clusters on-prem and some Kubernetes clusters in the cloud. And there are some use cases behind why you need multiple Kubernetes clusters. The first use case is probably the most obvious one, is a geographical separation. So if you have users in Asia and you have users in America, you don't want the request from Asia to go to the American data center. So you want to have multiple Kubernetes clusters, and you want it to be front-faced by some sort of the geographical GLB that would redirect the request based on the location to the appropriate Kubernetes cluster. And let's say you're actually fine with your request traveling from Asia to the United States, and you want to like install your Kubernetes cluster across regions, but Kubernetes will not be happy with that. Its components actually like being close to each other, and if you try placing your etcd components on like different geographical locations, you'll see what happens. And the Kube API server and Kubelet, they also like to be close to each other. So it is a recommended model that you place your Kubernetes component in one data center. So the geographical separation, the reason number one. The reason number two is the logical separation driven by the security reasons. So you might want to have your production cluster being completely separate from your development. And you want to be very, very careful when it comes to securing your cluster. Because Kubernetes by itself is not hard multi-tenant. So if your cluster is if your API is compromised, if your API server is compromised, your entire Kubernetes cluster is going to be in trouble. So you might want to secure your production cluster better and more carefully than you would secure your development cluster. And it actually depends on the team on how many security checks they want to run on the cluster. Some clusters, they actually have a very short life cycle, so users or administrators, they just want to launch Kubernetes clusters and then kill it during the same day. So they don't have to be that careful with the security. So logical separation driven by the security reason is the reason number two. And the reason number three is my favorite one. Logical separation driven by the functionality reason. So I'm not sure if in your organization you have teams that want to be on the hip side and they want to run all the latest and the greatest in their Kubernetes cluster. But I've definitely worked with a team like that. Some teams are more traditional, and they are fine with the approaches that are probably old, but they work, and they don't need anything else. So it's like they're fine with a Docker runtime interface, and they're fine with a Nginx as an ingress controller. They don't need anything fancy. They just need the application to run. And other teams, they want to try all things new. They want to try CRI-O as a runtime interface. They want to do Istio instead of the load balancer. And they want to do the picks when it comes to their cluster provisioning. And yeah, different teams might have their different best practices. And it's fine to give them that flexibility when it comes to the Kubernetes cluster installation. So just to reflect back on three reasons: geographical, then logical reason driven by the security, and logical reason driven by the functionality preferences. So in order to address three challenges and to install and manage different types of clusters under the same hood, we need some sort of the centralized management system for Kubernetes cluster provisioning that would work anywhere, whether on-prem or in the cloud. Then you would need to have some centralized authentication and authorization system that would actually authorize the user access to the Kubernetes clusters. And then for you who know Kubernetes, and for those who don't, Kubernetes is very flexible when it comes to configuring add-ons like the DNS, load balancing, or monitoring. It lets you to install the bare-bones Kubernetes, and then you can launch your add-ons as the Kubernetes native applications. It can be done after the fact. So we need some sort of the centralized add-on manager where you can store all your add-ons, and there you can deploy them to any Kubernetes cluster under the same umbrella. All right, so at Rancher, we kept calm and we accepted that challenge. And we built an open source platform to managing multiple Kubernetes clusters. And we took care of everything, starting from the cluster provisioning, that actually might include even the virtual machine provisioning, where your Kubernetes cluster is going to be launched. And we wanted it to work everywhere in the cloud and on-prem. And then we've built a multi-management platform on top of it, and then provided the good user experience to the user by giving the UI and API, and by giving the native kube control access to the Kubernetes clusters. It's completely open source. We don't have any proprietary features. We just charge for support if support is what's needed. Our community is pretty big. The community of open source users is very big. And we take the user bug requests as serious as we take the customer's bug requests. So let's go challenge by challenge. The first challenge was the provisioning, and it proved to be the most time-consuming one and the complex one when it came to choices. There are some provisioning use cases that we wanted to cover. The first one was obvious. It was about launching Kubernetes clusters on the public cloud providers that supported Kubernetes as an offering, and it was pretty obvious. You just have to integrate with their APIs. The only one that was not clear was like EKS. At that time, it was in beta, but we managed to have an access to their beta APIs, and we started integrating with that before it actually came out. The second requirement was that Rancher provisions the host in the cloud and then install Kubernetes on them. And there are two things to address here. The first was the provisioning of the virtual machines, and the second one was the provisioning of the Kubernetes. And the requirement number 3 was that user provisions the host. It happens a lot on premises when the user has a set of hosts. And then Rancher will install Kubernetes on them. And again, in the implementation, we had to either choose among the existing Kubernetes installers or to develop our own. So when it came to the virtual machines provisioning, going with the Docker machine was an obvious choice. It was well tested and it is well adopted, so we just went with it. But choosing Kubernetes installer was not that easy. So the kops was a no-go because it worked only on AWS, and we couldn't afford to just have a separate set of installers depending on the cloud because it introduces like multiple code paths and it's not easy to test and validate. And then we started evaluating the generic installers like kubeadm and kubespray, and each of them had a different set of challenges. Some of them were slower than others, and configuring them was not easy as well. So we actually choose to write our own Kubernetes installer that is called RK. It's also open source. And that can be used to deploy Kubernetes anywhere. It can be done on EC2 hosts or on GCE hosts or on-prem. It can also run as a standalone tool as well as a driver. And it launches Kubernetes in a Docker container, and it's ready to go. And the fun part is we chose to release it as a standalone tool, and it was a very good decision because users started adopting and testing it, and they helped us to find some very good bugs that we fixed before we actually started integrating it with the rest of the Rancher components. So we wrote a layer that was given an integration point for all the drivers out there, like a GKey, EKS, AKS, and RKey. Here I just put an example of the driver interface. It's pretty simple. It's a create cluster, update, scale, and remove. And it's called Container Engine. It is also open source. So if the user chooses, if any other cloud provider enables Kubernetes as an offering, and user or customer really, really wants it, they can just go ahead and write the driver and just plug it in, or wait for us to write it. So we wrote this layer called Container Engine. And then we built a management layer on top that would talk to the Container Engine based on the user API. So the user says, create a cluster on the API server, and then the request would go to the Container Engine. We'll ask to provision the cluster, and Container Engine, based on the config, it will choose which driver to invoke in order to build that cluster. And then API server would talk directly to the user cluster once it's provisioned to monitor its health and to recover if something goes wrong. And it will talk to the user, to the Kubernetes cluster in order to install the add-ons or any user applications. So we build this management layer on top. And here I want to share some of the challenges that we faced when building this management layer. And we went through a number of iterations, and for me as a developer, it was quite painful, but it was fine nevertheless. So Rancher 2.0 version 1 was written in Java, and was using MySQL as a database. And the reason behind that was because our first version of the product was also written in Java, and everybody was comfortable, and it was working well. And we had some microservices written in Go. And here we also chose that Rancher agent that gets deployed in every Kubernetes cluster was also written in Go. And we thought that this model would work. And I have nothing against Java. I've been a Java developer for 7 years, and I like the language. MySQL is also a great database, but it proved that it was not good for us. And here are some reasons why it was not good. So as the majority of the components like Docker, Kubernetes, they're written in Go. And all other microservices that we developed are written in Go. So that implied that there was a lot of conversion between Java and Go. And although it might seem simple, there are always issues in that. And then there was a big diversion when it came to talking to the management layer and talking to the Kubernetes clusters. And then there was a big split between Rancher APIs and the Kubernetes APIs. And with a hard heart, we kind of realized, all right, so we actually have to rewrite the version 1. And we came up with the Rancher 2.0 version 2, which is actually, that is not just talks to Kubernetes or provisions the Kubernetes cluster. It itself built on top of Kubernetes, and it uses etcd as a database. So for you who program in Go, it uses Kubernetes as a vendor. It is written in Go. Its API does not replace the Kubernetes API. It extends the Kubernetes APIs. Every Rancher resource is a custom resource definition in the etcd database, and all functional components run as the Kubernetes controllers. And what is the custom resource definition, and what is a custom controller? You'll hear these words quite a lot once you decide to write the component for Kubernetes, or if you decide to contribute to one of the existing Kubernetes projects in the ecosystem. So we're going to talk a little bit about that. Kubernetes is a highly extendable development platform. You can extend many, many pieces of it. You can extend the container runtime interface. You can extend the cloud provider interface. And more important, you can extend the API by defining your own resources of resources or application as a custom resource definition, and writing the custom controller that would run actual logic for your application. As a benefit of using the custom resource definition, you get that you can use an existing command line tool to communicate with the Kubernetes API, or you can talk to the Kubernetes API directly, and the custom resource that you add would not look any different from the native Kubernetes API resource. So on this picture, I've presented the Kubernetes native components called pods and nodes. And then you can say kubectl get pod. kubectl is a command line tool to communicate with the Kubernetes clusters, and you'll get your pod bags. But let's say you're out to implement your own alert system. You can define your own custom resources. You can plug them into the Kubernetes API. And when you say kubectl, give me an alert, it would understand, and it will give you the object that are very specific just to your application. So Kubernetes was developed this way to avoid their main code base from growing. So if you look at the contribution to the Kubernetes main repository, you will see that they do not accept any specific components. So if you are to write your to your alert or login system, most likely your PR will be rejected, and you'll have to develop it like your own tool, and you'll have to launch it as a Kubernetes native application, meaning it's like a microservice that runs as a Kubernetes pod. And now, what is a custom controller? Custom controller is the microservice application that gets launched in the Kubernetes pods and that runs an actual logic behind your custom resource. So when the user creates a custom resource using the API, your controller will actually do all the job by doing of what is needed by the application. Like the alert is generated, what needs to be done, like this alert needs to be published somewhere. So custom controller will take care of it. So it works in a way that it watches for the resource creation, and then it runs the logic. So on the big picture, this custom resource definition and controller model was very good for us because our management controllers and for the management layer and the controllers that were talking to the Kubernetes clusters, they weren't different in design. So like you didn't have to switch your mindset when you came from working on the management piece of the code to the to the user cluster piece of the code. The logic is still the same, the approaches are the same, the libraries are shared, so it worked quite good for us. So to reflect on the lessons learned that we faced during the writing the provisioning part, so be careful when choose to use a third-party software for the key component of your application. So the decision to develop our own Kubernetes installer proved to be very good for us because we can control the release management, we can apply the performance fixes faster, and so we are in control of this key part. So if possible, release the part of the project as a standalone tool so it can get to the testing stage really fast and your community can test it for you. And when writing an integration to software, consider using the same development stack as the software you're integrating with. I understand that in most cases it might not be possible, but in cases where it's possible, it's a highly advisable way to do things. All right, challenge number 2, authentication and authorization across Kubernetes clusters. So as you can see in the organization, when you have multiple Kubernetes clusters, you want to be able to configure your authentication and authorization just once, although Kubernetes gives you a way to do it on the user cluster basis. But imagine you have like tens and hundreds of clusters. You don't want to do it that many times. So there are some things that we had to address. So we had to provide the unique experience across different types of clusters, whether it's G key, R key, or any cluster on-premise or in the cloud. And then you had to manage user permissions across clusters. And the third challenge was to prevent user from gaining too much access to the underlying infrastructure. So we had not only protect the authentication authorization, we had to protect the infrastructure based on the user permissions. Unified authentication was quite easy. We were using some parts of our RBAC code base. So Rancher sits an authentication proxy in front of all the Kubernetes clusters. So administrator just configures the authentication authorization just once, and it gets applied to every Kubernetes cluster. And the Rancher will validate the request, and it will use the impersonation before sending the request to the Kubernetes cluster. And we have an integration with the major authentication providers like GitHub, LDAP, you name it. And we keep on adding more based on the user and customer requests. And then a little bit more about the authorization. So Kubernetes has this native thing called RBAC, which allows you to define the permissions on per resource basis. So you can say that user A can only list the nodes. It cannot create or delete them. So based on the resources and based on the users, you can define of what a particular user can or can't do. So the example, like there are two key concepts. The first one is called role. The role is where you define of, for example, that the node has just list permissions. And then when you have a user, you create some sort of a role binding between the role and him, saying that the user is authorized to use this role. So Kubernetes has something. And in Rancher, we chose to extend the RBAC capabilities of the Kubernetes. And we introduced the concept of the project that allows you to group the Kubernetes namespaces. So you only have to apply your RBAC rules once on per project basis. And we do all the heavy lifting of pushing the RBAC permissions all the way down to the Kubernetes. So it is enforced on the Kubernetes cluster level, but you don't have to repeat the same set of the RBAC rules on all the namespaces in your cluster. And also we added, we made it easy to actually just add user to the project, and it will automatically inherit all the project's permissions. So if you were doing it on the vanilla Kubernetes, for every user that you add, you have to define this user role. So we do it automatically. Once the user is added to the project, all the roles are automatically inherited. And here is that, I just put an example of Rancher RBAC controller, of how it actually works. As I mentioned, all our logic is run as the Kubernetes custom controllers. So the controller listens on the namespace creation on the Kubernetes cluster. Then once the namespace is created, it goes back to the Rancher management layer. It pulls down all the permission of the project, and it applies them to the namespace. So it sounds quite easy, and it is easy. So once authentication and authorization is configured, it is time to protect infrastructure level of your cluster. So the Kubernetes has something called the pod security policy that lets you define of what is possible on your cluster. So it's like, for example, you want to prevent running the pods with the root privileges on the host in this cluster. Or you want to prevent the pods from accessing certain volumes type or host ports. So Kubernetes has a thing for it called pod security policy. And with Rancher, we just try to make the user experience better by configuring pod security templates where you can define everything that you could define in the pod security policy. And then you can choose this predefined template and apply it to either to the entire cluster or to a particular project in the cluster. So we did not introduce anything new, we just tried to enhance the user experience. And then another thing, sometimes in your organization, you want some sort of a network isolation. So by default in Kubernetes, all the pods can talk to each other. If you launch them even cross namespaces, they can talk to each other. And in the real world, of course, you would like to enforce some sort of the rules. And network policy, another Kubernetes native concept, is an easy way to do it. So you can configure a network policy that disallows an access from one set of pods to another set of pods. And that's a sort of a way to actually enforce the multi-tenancy in your cluster. So in Rancher, we wanted to leverage network policies to support the multi-tenants on the Kubernetes clusters. And I actually had a hard time on this picture trying to figure out how to name the projects. So the idea is the project A cannot talk to the project B, so I chose project Dev for one. And I was like, should I take project marketing? But marketing and Dev, they can talk to each other, they're fine. So I put a project HR. So you can have a project HR and you would like to disable all ways of communication or data transfer between the dev and HR. So automatically, once you create a project and you choose the correct CNI provider, this rule is enforced. Your project cannot talk to each other. Right, so reflecting on authentication and authorization, lesson learned. So try extending, not replacing the core functionality of the system you're integrating with. So before writing your own layer for authentication or authorization, just look at the system and see what it already has. Maybe it has a support for pluggable drivers or admission webhooks, or maybe it has its own set of RBAC rules that you can define. And also consider all the ways of making the system administrator work easier. Even if it seems it's obvious, like you can script everything, even if you have to configure things in like 100 places, it's easy to script, but now like try to think of how to actually enhance your user API and the user UI experience to make the things better. Okay, challenge number 3, managing Kubernetes add-ons. As I mentioned before, the Kubernetes is a very flexible system, and by default, I think it comes just with the DNS, but in the very, very beginning, it did not even have the DNS, so you had to install it after the fact. So here I put some add-ons that I use to enhance the Kubernetes capabilities. So they're like monitoring, logging, DNS, ingress controller, and the Istio and Linkerd, the service mesh. So add-ons extend the functionality of Kubernetes, and they get deployed as a native Kubernetes app, meaning that the application gets deployed in the Kubernetes pod. By the way, a Kubernetes pod, like I mentioned a lot, but think of it as just a Docker container in the Kubernetes system. Of course, it can run more than one container, but in the beginning, it's fine just to think of it as a container. And then upgrading add-ons does not require upgrading the entire Kubernetes system. Of course, there might be inconsistencies in some add-ons. Versions can work only with certain versions of Kubernetes. But the most add-ons that I've seen, they usually work fine across Kubernetes versions till some point. And here I've listed the most popular add-ons. The very critical one is the network CNI. So the Kubernetes doesn't come with the overlay network by default. You have to pick. And the most popular ones are Kalik, Flannel, and Kennel. And then for the DNS, there is a core DNS and Sky DNS. So the core DNS is a default in the Kubernetes 1.11. I'm not sure if anybody has preferences when it comes to the DNS components. SkyDNS proves to work just fine. But the core DNS is great because it is very extendable when it comes to integrating with external DNS providers. And then even the UI can run as an add-on. Like if you don't like the default Kubernetes UI, you're welcome to develop your own and run it as a Kubernetes native application that would talk to the Kubernetes API and display it to the user just the way you like. And the ingress controller. So what is ingress? Ingress is just a way of load balancing in the Kubernetes cluster. So think of it as a load balancer. And the most popular add-ons are Nginx, Traffic, HA proxy. And add-ons, and although add-ons are meant to be flexible, add-ons on the public cloud providers are not as flexible as you would expect them to be. So first of all, they're preset, and there is no real way to modify them. Well, the GKE allows you to disable the Kubernetes ingress controller, but that's about it. It doesn't offer you any other choice for the add-on installation. And the upgrades for the add-ons are not transparent. It's like you deploy the GKE cluster version 1, and then you upgrade your GKE cluster to the version 2, but you have no idea what's the version of the ingress controller that runs behind it. And you don't have a way to actually upgrade this ingress controller without upgrading the entire Kubernetes cluster. So in Rancher, we wanted to install the critical add-ons by default for users who don't have preference, but we also wanted to give enough flexibility to the advanced user who actually care whether they want to run SkyDNS or Core DNS, and who care about the particular version of the Nginx, for example, for the ingress controller. So add-ons on Kubernetes clusters provisioned by Rancher, they're configurable. And all the resources, by the way, can be configured using the Rancher UI API as well as the YAML files for those who work with Kubernetes. People seem to like it. So you can modify the YAML file here. You can modify the provider for your ingress controller or network plugin provider. So you can switch from Calico to Flannel and the other way around. Or you can even disable the add-on that you don't want to be installed by default if you want to manage it yourself and install it from some other source. So if user wants more fine-grained control over the add-ons, we provide the catalog experience where you can publish your add-ons in the catalog. That is, actually it is a Helm catalogs. And then after the fact, after your Kubernetes cluster is installed, you can pick whatever add-ons you want and install in your Kubernetes cluster. And then let's say the new version of the item comes out. All is need to be done that the catalog needs to be updated, and the change will be pushed to all the clusters. And it's not going to be forced push. It's like your add-ons won't automatically and magically reconfigure themselves. The administrator will just be given a notification that the new version of your add-on is out there. You have a choice whether to upgrade it or not. Right, so with all the lessons learned, I also wanted to emphasize our motto that we try to follow during all the development stages. Our main motto is no vendor lock-in. So we didn't want to lock the user to the cloud provider, and we didn't want to lock the user to any particular Kubernetes distribution. Like user can have its own preferences when it comes to whether he wants to run a vanilla Kubernetes or he wants to run their own options, and we didn't want to limit him in that. So no cloud provider lock-in, no Kubernetes version lock-in, no API and UI lock-in. So you're free to talk to your Kubernetes clusters directly using the kube control, the command line tool. You're also welcome to eject your clusters if you want to manage them outside of Rancher. We don't put any information into the user cluster that would prevent you from doing so. So you can import your cluster and you can eject it, and things gonna work like they worked before. And Rancher extends, not overrides the Kubernetes native functionality. So if you want to go again the native Kubernetes path, you're welcome to talk to your Kubernetes cluster directly. And yeah, so here on the slide, I'm not going to repeat that, but I've tried to list all the lessons learned during the developing multi-Kubernetes cluster tool. So be careful when choose the third-party software, overriding your own for the key part of your system. and then release as a standalone tool, and set up some nice defaults, but don't enforce user from actually installing their own components in the Kubernetes clusters, and try extending, not replacing the core functionality of the system you're integrating with. All right, KubeCon is demo time. I've got to make confession. So I was presenting at the last KubeCon, and I had a failed live demo. Did anybody else experience the same, like failed live demo? Yes. So I went ahead with the fix, and I was like, oh my god, I'm so lucky that I coded. And then during the live demo, it just failed in so many ways, and it was horrible. It was horrible. So not anymore. I know that having the quiz is pretty fun, but my motto for now is just don't do anything on the day of the presentation. Be happy with whatever you have. So you're gonna go and do the live demo. Is that big enough? Okay. So Rancher itself runs in the Docker container, and you can deploy it either on your laptop or in the cloud. There's just one command that launches the container with Rancher in it. In this case, I run Rancher in AWS. I just provisioned the EC2 host myself, and I set up the authentication with the GitHub, so I'm logging in as my GitHub account, Alena 1108. So this is Rancher, and this is a global view. That's a view where you actually see all the Kubernetes clusters under the same hood, all the Kubernetes clusters that you've provisioned. So here you can see one of my clusters is DigitalOcean, another one is a Google GKE. But first, let's go and configure one thing. The most important one is authentication. So by default, Rancher comes with a basic auth where you just provide the username and password. Here I enabled the GitHub authentication, which is just like a two-step process. And I logged in as my account user. And I also have another member of my team that has an access to Rancher. Then after that is done, it is time to provision the clusters. And the cluster provisioning can take time, so I actually have a couple of weekend clusters. But we can go through let me just show the options that we give the user on the way that Kubernetes cluster can be added. So it can be added as a hosted Kubernetes provider. It can be added as a Kubernetes installation in the cloud, in which case we will do the nodes provisioning like for EC2, Azure, DigitalOcean, and vSphere. You can import your existing Kubernetes cluster into Rancher, which you can eject later on if by some reason you're not happy with us. Or you might want to have your nodes already provisioned and you just want to use us for Kubernetes cluster installation. The custom options for you. And then just to give an idea of what the options can be there during the cluster installation. So you are to pick what Kubernetes version you want to use, which network provider you want to configure, whether you want to enforce the network isolation for your cluster, whether you want to ingress or not, and then whether you wanted the security policy support. So if you wanted, just click Enable, and here you can click from the list of preset security, pod security policies that will apply to your cluster. So in this case, actually, I want Rancher to provision the nodes for me. So I created this DigitalOcean template, which is just a template for virtual machines provisioning in the DigitalOcean that includes the region and CPU memory, stuff like that. And here I just pick which roles I want for my cluster. By the way, it's like if you run Kubernetes in production, don't do this. Like, don't put all the roles on one of the nodes. Try to separate your etcd as it's the most sensitive part of the Kubernetes application. And yeah, etcd and control plane, just make them separate and then run workers on the separate node. All right. So I have 2 Kubernetes clusters. And then what you can also do, so I'm authenticated as a GitHub user, and I'm administrator in this cluster. I can define the roles for the users that I want to add from my project. So I can add a project role. And here you can say which resources you want to grant access to. It's like I want the user to be able to create clusters, or to list them, or to patch. Patch is just a fancy way of updating things. Or you can inherit from the existing roles. It will inherit all the permissions. And then this role can be chosen when you go to your project. So in my case, I have 2 clusters. Under each cluster, I have 2 default projects. One is default in one system. System is where all the Kubernetes add-ons are running. So if I go to the default project, and then I can go to the project members, and then that's where actually I can add the member. The GitHub search will be invoked, so like if I type, if I type any GitHub user, and then I give him the permissions. I can either give him the member permission, which is a preset role, or I can define my own. I don't know this user, so I'm not going to add him. I just used him or her as an example. All right, so once the cluster are provisioned and users are defined, it is time to actually talk to your clusters and deploy their applications. And there are several ways to do that. You can do it from the UI. You can do it from the API. So basically every resource, if you just do this, view an API, you'll see the Rancher APIs that you can use to launch your resources. You can also script it if you like, but it's just a nice way of seeing what API fields are out there and their types and stuff like that. Okay, switch. Right. Or you can go through our UI and deploy your workload on Kubernetes. So here I just wanted to deploy an Nginx application. And I would like to publish a port. And I know that my container port is 80, and I want to publish this port on every node. And I don't care what this port is going to be. So I just say random. Oh, and yes, I would like my application to consist of 1 pod, so I just say 1 pod. There are more options, like you can either run 1 pod on each node. So it's going to be translated to the Kubernetes daemon set, or you can do a stateful set or job or cron job. And yes, you pick the namespace where you want your application to launch. And then you click launch. So what it does, the Rancher talks directly to the Kubernetes API and deploys the deployment in this case. And it gives you now something back. It gives you the access point for your application. Right, so now you can talk to Nginx. So UI API, and then the third way of talking to your Kubernetes cluster, you can do it using the kubectl. So you can either do it here, the command line. You can either launch it directly in the UI. There you go. Or you can copy-paste the config file and run the kubectl tool from your local machine. So actually, from my side, thank you all for coming and listening. You can find me on Twitter and GitHub. I'm trying to be active in both places. I'm probably more active on GitHub than I'm on Twitter. So if you have any questions, feel free to reach out, and I'm going to be here for a couple more hours if you want to talk.